And really what I hope you see with these two problems is that this way is perfectly fine, but notice that this way works for this problem as well. You can absolutely do this problem with integration by parts too, but as far as I know, this is like the most efficient way to do it. Notice what he did. You pull one cosine out, then you turn the cosine squared into 1 minus sine squared. Really, you did the same thing here. You pulled one cosine out, and then you turn the cosine to the fourth all into sines. So it should be easy now to do cosine to the 11th. The only hard part about it would be what? It's cosine to the 10th of x times cosine of x dx, right? So far, so good. What's cosine to the 10th? Well, it's cosine squared to the 5th. I'm going to put it right in the x's. Right? Cosine squared to the 5th is cosine to the 10th. Cosine squared is what? 1 minus sine squared to the 5th times cosine. Now, the only hard part is multiplying 1 minus sine squared to the 5th out. But it is just algebra, right? And the first one's going to be 1, because it's going to be 1 times 1 times 1 times 1 times 1, 5 times. So you're going to have just a cosine. So you know that the first thing in this one is going to be sine plus something. Now, there's going to be a whole bunch more terms get multiplied out. So I don't know what the next one's necessarily the coefficient of it's going to be, but it is, and the last one's going to be a sine squared to the 5th is going to be a sine to the 10th. So plus dot, 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 plus the last one's definitely going to be a sine to the 11th with a coefficient out front. Because this is going to be a sine to the 10th times cosine, so it's going to be like 1 over 11th sine to the 11th. Now, I'm not going to work out all the algebra to multiply that monster out, but I can at least see what the pattern is. The first one's going to be a sine. The last one's going to be a sine to the, I said 11th. Let's see. Yes, because it's a sine to the 10th, and I'm going to add 1. Yes. The last one's going to look like that. So at least I got the first and the last. And then I'll just put trivial to fill in the blank.
So if you have trig functions greater to the power of 2, pretty much want to break them down into squares.
Depending on whether they're even or odd. For odd trig functions, this trig strategy is your technique. For odd trig functions, pull one of them out. If it was cosine, if it was sine to the 5th, yank one sine out, turn the other forward, cosine.
Couldn't it work for evens too, though? If you had maybe cosine of 6, you'd have 3. Well, I don't know.
The problem is you need the extra one for your du out here, right? The key that this worked is that you have a cosine, you have a sine squared times a cosine, you have a sine to the 4th times a cosine. That du is cosine.
Okay.
That's why this works. And it won't work with even because you have a sine cosine squared there, retain the derivative of sine to the 4th. Okay, let's go to the back. Who's up? 227. Oh, that's Zach. Okay, Zach's trying to find us the pattern. Cosine